Hey everyone, and welcome to this explainer. I want you to just take a quick second and look around you. Right now, whether you're sitting at your desk, chilling on the couch, or walking outside, there is this massive, invisible force that is literally holding our entire reality together. We experience it every single second of our lives, right? But we rarely pause to actually think about the absolute mystery of how it works. So today, we're unpacking the real mechanics of gravity, and we're going to translate some pretty complex physics into concepts that you can actually see and understand. To really wrap our heads around this, I want you to imagine a totally different reality. Just picture holding an apple in your hand. You let it go, but instead of dropping to the floor, whoosh, it shoots straight up into the sky. No way, right? Or imagine if, instead of standing firmly on the ground right now, you suddenly just started floating in midair, drifting around exactly like an astronaut up in space. Now, obviously, we all know that doesn't happen. And we know the word for why it doesn't happen, right? Gravity. But here's the thing. Knowing the word and actually understanding the mechanism behind it are two very different things. How does an invisible force just reach out and pull things together? What is actually going on in the literal space between you and the ground right now?
Part 1, the 1687 breakthrough. Okay, let's dive into this, because this is where Sir Isaac Newton totally changed human history with his realization that absolutely everything with mass attracts everything else. Now we have this famous formula here on screen. F equals G times M1 times M2 divided by R squared. I know, it kind of looks like a lot of intense math, but let's actually translate that into plain English, because the rule is brilliantly simple. Basically, the more mass an object has, the stronger its gravitational pull. It's kind of like a giant cosmic game of tug of war. So the real reason you don't just float away into the clouds isn't magic. It's simply because our Earth is just so unimaginably massive, and its incredible pull is exactly what keeps us firmly planted on the ground.
But here is the massive plot twist. For over 200 years, the entire scientific world totally accepted Newton's idea of this mysterious pulling force. But then, in 1915, Albert Einstein enters the picture and completely shatters that 200-year-old idea. Einstein basically said, well, Newton was right about what gravity does, but he was totally wrong about what causes it. He realized that gravity is actually not a mysterious tether reaching out to grab you. Instead, it's the physical bending and curving of space-time itself. Crazy, right?
Which brings us to part 2, Einstein's magic and the space-time fabric. This is where things get really mind-bending, because Einstein revealed that gravity isn't a pull at all. It's actually the result of this invisible woven fabric of space and time bending around super heavy objects.
And this brilliantly illustrates exactly how it works. So imagine you're stretching out a large rubber sheet so it's completely tight and flat. That right there is our space-time. Now, step 2, take a really dense heavy ball, let's say that's our sun, and place it right in the middle. It immediately sinks down and creates this deep bowl-like curve. Finally, step 3, take a small marble representing our Earth and just give it a little toss onto the sheet. Notice how it doesn't get pulled straight to the middle like it's magnetized. Instead, it naturally rolls along that curved dip, looping endlessly around the heavy ball. It's an absolute game changer when you realize that heavy objects simply bend the universe and lighter things just follow the curve.
Moving on to part 3, the survival stakes and why gravity actually matters. Okay, so we've been talking about theoretical physics and rubber sheets, but let's get real for a second. What would actually happen to our survival down here on the ground if this invisible space-time fabric suddenly just stopped curving?
Well, the consequences would be absolutely catastrophic and literally instantaneous. First off, boom, our entire atmosphere instantly vanishes into the cold, empty vacuum of space. And the oceans, they wouldn't just sit there in their beds. The water would literally detach and start floating skyward. Then, without the deep gravitational curve of the sun keeping us safely in our orbital loop, Earth would start drifting away into freezing darkness. And ultimately, our entire solar system would completely break apart and scatter into the void. So yeah, without gravity, we lose our air, we lose our oceans, and we lose the whole shebang.
So, the very next time you take a simple step, or maybe drop something off your desk and watch it fall, take just a brief moment to thank the rules of the universe. Honestly, we should all appreciate that deep, invisible curve in space-time that's generously keeping the air in our lungs and keeping our planet perfectly warmed by the sun. But, you know, it really does leave you wondering, if a profound invisible bending of space dictates literally our every move without us even seeing it, what other invisible forces are secretly shaping our reality right now? Keep learning, keep exploring, and I'll catch you in the next explainer.